I welcome you all to this mathematics class. I'm Ms. Vandana Gupta, Assistant Professor of Mathematics. We have already started with section 2, statistics, in that unit 4, elementary probability theory. This unit has got two subunits. First one is probability theory. The second one is random variable. I think in the last week itself, we have started with probability theory, and some 5 lectures I have taken on this. Today, again, I'm going to continue with this. Today, some two important things we are going to study: addition theorem and multiplication theorem. These are the things which you already know. The sample space, quickly we will revise. Sample space is the collection or set of all possible outcomes of a random experiment. You know what are event? Event is any subset of the sample space. Then we know what are types of event. All these things we have already done, so I'm quickly revising it. Impossible event is an event which can never occur or which has no sample points in that. Certain event means the sample space itself is a certain event which is surely going to occur. Then yesterday we have seen what is the union and intersection of two events. So if A and B are any two events, then the occurrence of either of the two events, either event A or B, is called as the A union B, and it is denoted by this U for union symbol. Here I have taken one example to illustrate that. If you take the random experiment of rolling a dice, then you know that its sample space S contains these 6 sample points. These are all the possible results of that experiment: 1, 2, 3, 4, 5, 6. If I take A, B, C as the events, A is the event of getting an odd number, the uppermost face of the dice. B is an event of getting an even number, and C is an event of getting a number divisible by 3. I have taken these 3 events and tried to show you how to find out A union B, or the union of two events. So to write down the union of two events, once again, how will you do? You first write down the sample points of A. What are the sample points in A? 1, 3, and 5. So we will write down 1, 3, and 5. And then from B, we will write down those sample points which we have not written here. So they are 2, 4, and 6. None of them we have written here, so I will write down them. So A union B is 1, 3, 5, 2, 4, 6, which is nothing but our sample space S. Similarly, we can find out A union C and B union C. For A union C, first of all, you write down the members of A. They are 1, 3, and 5. C contains 3 and 6. Out of that 3, I have already written. So I will only write 6 now. So A union C is 1, 3, 5, and 6. So if I throw my dice, and if I get any of these 4 numbers, then I will say that my event A union C has occurred. Okay. So if either A or B occurred, we say A union B has occurred. Similarly, we have defined what is intersection of events. If A and B are any two events, then occurrence of event A and B both simultaneously, this word both is important here, both occur simultaneously, then we say that intersection of the two events has occurred, and it is denoted by A intersection B. Similar examples I have taken here. To find out A intersection B, look at what is common in A and B. You see that A and B has no sample point in common. So A intersection B is an empty set. It has no sample point. Such a set, we call it as impossible event. Okay. Similarly, A intersection C. A and C, we have to see what is there in both. It is 3. So when you roll a dice and 3 comes on the uppermost face of the dice, then you say that the event A also has occurred and event C also has occurred. So both the events had occurred. So that means A intersection C has occurred. So to write down the event A intersection C, we have written the sample points which are common to A as well as to C. Okay. Then we have defined mutually exclusive events. Two events are called mutually exclusive if they cannot occur together. That means if one occurs, the other one will not occur. So occurrence of one will restrict the occurrence of the other. Or in the language of mathematics, if two events are mutually exclusive, then they have no sample points in common. That means their intersection will be empty. So in this example, A and B are mutually exclusive because both of them cannot occur together. A is a set of odd numbers and B is a event of getting an even number. And there is no number which is both odd and even. So these two events will not occur together. Okay. So, and you can see that there is no number which is common to both. So A and B are mutually exclusive events. Whereas A and C, these two events are not mutually exclusive because both of them are having 3 common. So if I roll my dice and if 3 occurs, then A also has occurred and C also has occurred. So I cannot say they are mutually exclusive. So A and C are not mutually exclusive events. Then we have seen what is exhaustive events. Exhaustive events means what? Two events are called exhaustive events if A union B is the entire sample space S. If you unite A and B, then you get the whole of the sample space. Such events are called exhaustive events. Look at here, A and B, A union B will be the entire space S. So A and B are exhaustive events. A union C is not exhaustive. If I take A and C, if I take the union, I will get 1, 3, 5, and 6. 2 is not there, 4 is not there. So this is not entire S. So A and C are not not exhaustive events. So we have seen what is mutually exclusive events and what is exhaustive events. Then we have seen if the two events are complementary events. What is the meaning of complementary event? Non-occurrence of an event A is called the complementary event. If A is any event of an experiment S, then non-occurrence of event A is an event which is called as complementary event of A. Complementary event, if you want to write down, you have to look at what are the sample points which are not in A, which are outside A. They are the complements. So A and A complement cannot occur together, correct? Because whatever is in A is not in A complement. They are totally, that is the way it is defined. A complement is outside A. Okay. So A and A complement cannot occur together. There is nothing common to them. So they are mutually exclusive events. Okay. A intersection A complement is empty. There is nothing common to them because A ke bahar hai A complement. And if you unite them, then you get the entire sample space. So this is a very good property of complementary events, that complementary events are mutually exclusive and also exhaustive. So that is what, and here I think I stopped yesterday. We could only do up to here. Complementary events are mutually exclusive as well as exhaustive. Okay. And then I had given you some homework problems. Today we will see the addition and multiplication theorem. So the first one, addition theorem, it states that if A and B are any two events associated with an experiment, then probability of occurrence of either of the two events, means either A or B, that means probability of A union B, it is given by probability of A plus probability of B minus probability of A intersection B. Okay, how we are getting this? This is by the set theory. You know that, suppose this is my set A or event A, you may say, this is my event B, okay, in the sample space S. Suppose this is my sample space S and there are two events A and B in this sample space S, okay. This is B. Now, if I want to count the number of members in A union B, what is A union B? It is either in A or in B. So this much is my A union B. Okay. So if I want to count the number of members in A union B, look at the diagram. First, I count the number of members in A. Then I will add the number of members in B. When I'm adding the members in A, if I'm adding the number of members in A and then adding the number of members in B, you see that this portion which is there in both A as well as in B, it is counted 2 times. First, when I'm counting the members of A, that means here, and next when I'm counting the members in B. So this middle portion, which that is A intersection B. What is this middle portion? It is the intersection. See, this is A intersection B. So the number of points here are counted 2 times. So I have to subtract here. So this you have already studied in school days in set theory. Number of points in 2 sets, I mean union of 2 sets, A union B, is equal to number of points in A plus number of points in B. Let me write it properly. Number of points in A union B is equal to number of points in A plus number of points in B minus number of points in A intersection B. Now divided by number of points in S. S means sample space. Both the side. Divide by this. Divide by n of S. So left hand side I will get number of points in A union B divided by number of points in S, number of points in A divided by number of points in S, plus everywhere divide by number of points in S. Left hand side as well as on the right hand side. So number of points in A intersection B, this also I will divide by n of S, number of points in A. Now look at here, what is number of points in A union B divided by number of points in S? It is nothing but probability of A union B. What is our definition of probability of a event? Number of points in that event divided by number of points in S. Similarly, number of points in A divided by number of points in S is nothing but probability of A. And this is probability of B. And what is the last one? Number of points in A intersection B divided by number of points in S is nothing but probability of A intersection B. And so this is how I get this theorem. Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. So this is how we have got this theorem. This one. So it is basically the application of set theory. You don't worry if you have not understood what I have just now explained you regarding the set theory. You only have to know this and how to use this addition theorem for solving the problems. Okay. So probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Now see this. If your A and B, so what formula we got? Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. This is what we have got. Okay. If your A and B are mutually exclusive, what is the meaning of mutually exclusive? Mutually exclusive meaning their intersection is empty. That means if A and B are mutually exclusive, then what will happen? A intersection B will be your empty set. Correct? That is the definition of mutually exclusive events. So what is the number of points in A intersection B? If it is empty, it will have no points. So it will be 0. So let us find out probability of A intersection B. What is your formula to calculate the probability of an event? It is number of points in the event A intersection B divided by number of points in S. What is number of points in A intersection B? You got 0. 0 upon n of S. 0 divided by any number will give you 0. So what we have got, that if A and B are mutually exclusive event, then what is the probability of that A intersection B? It is equal to 0. Okay. Now let us put this A here 0. So what will you get? You will get probability of A union B is equal to probability of A plus probability of B minus this is 0. Okay. So ultimately, what will you get? If it is 0, you can delete this. So what you have got is probability of A union B is equal to probability of A plus probability of B. U for union, matlab milana, correct? So that is why it is called as an addition theorem. Okay, probability of A union B is probability of A plus probability of B if A and B are mutually exclusive. Okay, mutually exclusive, if you want mutually exclusive मतलब there is nothing common to them. A इधर है, B इधर है, ऐसा है picture. So what is probability of A union B? It will be probability of A plus probability of B. लेकिन अगर आपके events ऐसे हैं, there is something common to them. ये A है, ये B है. This part is common to them. So in that case, how will you find out probability of A union B? It will be probability of A plus probability of B माइनस प्रोबेबिलिटी ऑफ ए इंटरसेक्शन बी, क्योंकि ये पोर्शन 2 बार ऐड हो गया तो यहाँ माइनस करेंगे. So here these events are mutually exclusive. तो जब भी कभी आपके इवेंट्स म्यूचुअली एक्सक्लूसिव है, मतलब उसमें कुछ भी कॉमन नहीं है, तो प्रोबेबिलिटी ऑफ ए यूनियन बी विल बी प्रोबेबिलिटी ऑफ ए प्लस प्रोबेबिलिटी ऑफ बी. और अगर म्यूचुअली एक्सक्लूसिव नहीं है, मींस देयर इज समथिंग कॉमन, नॉट म्यूचुअली एक्सक्लूसिव. So what you have to do, you must know, to find out the probability of A union B, you must know the probability of A intersection B also. Okay, so this is very important. That is what I have written here. See here, if A and B are mutually exclusive events, then probability of A union B is probability of A plus 1. This is what I had explained you just now. Now, one more important thing. If two events are complementary events, we have just now seen complementary events are mutually exclusive and exhaustive. So, if mutually exclusive है, तो उनका probability intersection, there is nothing in intersection. So, probability of A intersection A complement will be 0 because they are mutually exclusive. What is A union A complement? Because they are exhaustive. Look at here. A and A complement are exhaustive events, no? You know that complementary events are mutually exclusive as well as exhaustive. So what is the meaning of exhaustive? Exhaustive का मतलब है A and A complement will give you the entire sample space. Therefore, number of points in A union A complement will be same as number of points in S. So what is the probability of A union A complement? It is number of points in A union A complement divided by number of points in S. But number of points in A union A complement is n of S. So n of S divided by n of S will give you 1. So you will get probability of A union A complement equal to 1. Okay. But what is probability of A union A complement? According to my definition, according to my theorem, probability of A union A complement is probability of A plus probability of A complement minus probability of A intersection A complement. Because they are exhaustive event, this probability is 0. So you will get probability of A plus probability of A complement only. And this probability of A union A complement, just now we have seen, it was coming as 1. See here, probability of A intersection A complement was 0. Here, wait a minute. Here, probability of A union A complement is 1, correct? And what is probability of A union A complement? It is probability of A plus probability of A complement minus probability of A intersection A complement. This is equal to 1. but this is 0. Why? Because A as if is equal to 0, because A and A complement are exhaustive, are exclusive events. Exclusive events. There is nothing common to them. Therefore, this is 0. So what will you get finally? Probability of A plus probability of A complement is equal to 1. So this is again a very, very important thing. See here. Yes, probability of A plus probability of A complement is 1. So you have to remember two important things. One is this formula, probability of A union B is probability of A plus probability of B minus probability of A intersection B. And the other one, this one, probability of A plus probability of A complement is equal to 1.
रोल नंबर काय आहे? 47.
Okay. Now let us solve the problems based on these two theorems. Look at the first exercise. You are given probability of A equal to 0.7, probability of B equal to 0.3, and probability of A intersection B is 0.2. What is asked to you? Find probability of A union B. And second one, find probability of A complement. Let us see how will you find out probability of A union B. So apply your formula. What is your formula to calculate probability of A union B? It is probability of A. All these problems are based on this formula only. Okay. What is probability of A? How much it is given? 0.7. And probability of B? 0.3. So this is 0.7 and this is 0.3. What is probability of A intersection B? It is 0.2. So just put the values. Simplify this, you will get 0.8. Therefore, what we have got, probability of A union B is 0.8. So you got the answer for the first one, 0.8. Okay. What is the second one? Find probability of A complement. आपको probability of A दिया है और probability of A complement निकालना है. I told you probability of A and probability of A complement दोनों को आप add करोगे तो answer 1 आएगा. Remember that probability of any event and probability of its complement. If you add, you will get 1. Okay. So you know that for second, if the first one, second one, probability of any event A plus probability of its complement is 1. Okay. What is given to you? Probability of A is given to you at 0.7 and A complement you have to find out. So this is given to you at 0.7 and this you have to find out, A complement. What will you do? Probability of A complement is 1. 0.7 को आप उधर शिफ्ट कर दो तो 1 minus 0.7. So you will get 0.3. Therefore, probability of A complement is 0.3. Basically, probability of A and its complement should be 1. Answer should be 1. 0.7 plus 0.3 is 1. So if you know the probability of any of the event, you can find out the probability of its complement by subtracting from 1. Okay. So we have solved these two problems. Now, इस problem में आपको probability of A union B A union A intersection भी दिया था और आपने A union B निकाला. Problem number 1 है ये. Exercise number 1. Okay. So this what I have done here is this one. Exercise number 1. Okay. Let us see the problem number 2. Here, this is problem number 2. In this, probability of A is given at 0.5. Probability of B complement दिया है आपको कितना 0.2. Okay, and you are also given probability of A union B, that is 0.9, and you have to find out probability of A intersection B. Apply करना है वही formula. Okay, so look at what is the formula. What is your formula? Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. इसमें 4 things are there, 1, 2, 3 and 4. If you know any three, you should be able to calculate the fourth one. In the previous problem, you were given this, this, and this. So you have calculated probability of A union B. In this problem, problem number 2, you are given A union B. ये probability आपको दिया है और intersection का पूछा है. So what are the things given to you? Probability of A is given to you at 0.5. This is given to me 0.5. Am I given probability of B? No, B bar दिया है मुझे. तो probability of B मैं निकाल सकती हूँ. कैसे? देखो, we know that probability of B plus probability of B bar is 1. इन दोनों में से मुझे B bar का दिया है, complement का दिया है 0.2. Look at here. Probability of B plus probability of B complement is 1. Probability of B मुझे निकालना है. B complement का मुझे दिया है 0.2. So what will be the probability of B? It is 1 minus 0.2. That will give me 0.8. So I got probability of B as 0.8. Let us put all the values there. So 0.8. Okay. And probability of A intersection B I have to calculate. So this I will keep as it is. Okay, this I have to calculate. Okay. Now what I will do, this A union B भी मुझे दिया है. कितना दिया है? 0.9. This is given to me 0.9. Now I have to simplify this equation and find the value of probability of A intersection. If you want for your simplicity, आप इसको x भी बोल सकते हैं. So what I can do is 0.5 plus 0.8 minus इसको अगर मैंने x बोला. Now you have to solve this equation and find the value of x. So 0.5 plus 0.8 will give me 1.3 minus x. That is equal to 0.9. So what will be the value of x? Minus x you shift here. So it will become plus 0.9 you shift right side. If you just a solution of the, how do you solve the equation? Now 1.3 minus 0.9 will give you 0.4. So x is equal to 0. What is x? Let x be probability of A intersection B. Therefore, probability of A intersection B is equal to 0.4. This is the answer. See here, 0.4. So basically in this formula, whatever is given to you, you can write down the, put the values and solve the equation. Look at what is the second question. Find out probability of A complement. Probability of A दिया है, A complement निकालना है. कैसे करेंगे? Probability of A is given to you and you have to find probability of A complement. How will you do that? We know that, what we know? That probability of any event plus probability of its complement, if you add, you get 1. Right? So remember this formula. Probability of A plus probability of A complement is 1. Probability of A is 0.5. And this you have to calculate. A bar ka. Okay. So therefore, what is probability of A complement? 1. 0.5 shifted to the other side will give you minus. So 0.5. So probability of A complement is 0.5. Okay. So this is how we have seen today the applications of these two formulae. 1 minus 0.5. Okay. So basically, what we have done is in these two examples, these two formulae we have used. This one and this. Okay. I'll give you more problems for practice. So we have seen what is mutually exclusive event, exhaustive event. One last definition, independent events. If the occurrence or non-occurrence of an event A is not affected by occurrence or non-occurrence of event B, then such two events are called independent events. What you have understood with this? अगर एक इवेंट अकर होगा या नहीं होगा, उसका दूसरे इवेंट के अकर होने या ना अकर होने से कुछ भी रिलेशन नहीं है, then such two events are called as independent event. Means they are independent of each other. एक का दूसरे से कोई भी सरोकार नहीं है. Such events are called independent events. Let me give you an example of that. Suppose there are 5 questions in a question paper and one student, there are 2 students, okay? Student number 1 and student number 2, or student name A and student name B. Okay, there are 2 students and there are 5 questions in the question paper. Student A and student B. Okay. Suppose A can solve 2 questions out of 5 and B can solve 3 questions out of 5. Okay. So the probability that the question is solved by A will be entirely independent of the probability of that. I mean, the event that the question is solved by student A and the event that the student B has solved the question are totally independent. So this is the definition of, this is the meaning of independent events. One more example I can give you. Suppose आप 52 cards में से you are taking out 2 cards. Okay, my event A is I defined as both the cards are king cards. Both are king cards. What is my event? If I take out 2 cards, then both the cards are king cards. One by one, I'm taking out the cards. Okay. So, see, let me explain you once again. Suppose the first example, I hope you have understood. If student 1 is answering the question or student 2 is student B is solving the question, there are 2 independent events. One has occurrence of one has nothing to do with the occurrence of the other. Similarly, from a pack of 52 cards, if you select one card, only one card, and suppose my event is that that card is a king card. If that card which you have selected, if you again replace it in the pack, and then again one more card you take out, and again my event is getting a king card. So these 2 events will be independent of each other. पहले आपने कार्ड को सफल किया, एक कार्ड निकाला, and my event is that that card is a king card. फिर जो कार्ड मेरे हाथ में आया उसको मैंने वापस उस पैक में डाल दिया और फिर मैंने शफल करके फिर एक कार्ड निकाला. आई एम टेकिंग आउट 2 कार्ड्स बट नॉट दोनों कार्ड साथ में. पहले मैं एक को निकालती हूँ, फिर उस कार्ड को रिप्लेस करती हूँ और फिर 52 कार्ड्स में से वापस से दूसरा निकालती हूँ. तो दीज 2 इवेंट्स आर इंडिपेंडेंट इवेंट्स. लेकिन अगर मैं ऐसा बोलूं कि 52 कार्ड्स में से आई एम सेलेक्टिंग वन कार्ड एंड उस कार्ड को मैं निकाल के साइड में रख देती हूँ, ठीक है, और फिर बाकी के 51 कार्ड्स में से दूसरा कार्ड निकालती हूँ, तो नाउ व्हाट आई एम गेटिंग, दीज 2 इवेंट्स विल नॉट बी इंडिपेंडेंट टू ईच अदर. व्हाई? यू नो, बिकॉज सेकेंड अटेम्प्ट में अगर मेरे हाथ में जो कार्ड आ रहा है दैट आई एम पिकिंग अप फ्रॉम 51 कार्ड्स, क्योंकि पहले अटेम्प्ट में मैंने जो कार्ड निकाला था उसको मैंने साइड में रख दिया. अगर वो कार्ड किंग कार्ड होता है तो मेरे लॉट में सेकेंड अटेम्प्ट में किंग कार्ड की संख्या कम हो जाएगी, 4 की जगह 3 हो जाएंगे. So my second event depends upon the first event. Okay, I hope you have understood. So you just remember that independent events means occurrence of one event does not, I mean, it has nothing to do with the occurrence or non-occurrence of the other event. Now, जैसे हमने एडिशन थ्योरम किया था वैसे यहाँ मल्टीप्लिकेशन थ्योरम है for 2 independent events. So if A and B are 2 independent events, then probability of A intersection B is probability of A into probability of B. That's all you have to remember. If A and B are mutually exclusive event, then probability of A union B is probability of A plus probability of B. That is addition theorem. But if A and B are independent events, then probability of A intersection B will be probability of A into probability of B. Okay, so thank you.